Hello there. Welcome to Info Jungle. This is where curiosity slows down, where the world feels a little quieter. Tonight, we're heading into a place that feels both ancient and strangely untouched by time. A place where the surface world fades away, replaced by pressure, darkness, and life shaped by forces we barely understand. But before we go any deeper, I'd like to know something grounding. Where are you watching from tonight? And what time is it for you? Your check-ins always feel like small warm lights scattered across the darkness. Each one a reminder that while we drift into hidden places, you're somewhere safe, steady, and still. If slow science, quiet exploration, and gentle deep-sea journeys help you rest, feel free to like the video or subscribe. Only if it feels right for you. This is a calm corner of the internet. And nothing here happens in a rush. So let's begin. Tonight's journey is about giants. But not the giants most people think of. We're not talking about the whales that breach at the surface, or the sharks that glide through coral reefs. We're going far deeper than that, into regions where sunlight cannot reach, where pressure builds like a silent weight, and where creatures evolve along paths utterly different from anything on land. For thousands of years, humans have wondered what lives in the deep. Old sailors spoke of monsters. Myths described serpents longer than ships, shadows beneath waves that stretched farther than imagination. Most of those stories were exaggerations, but they weren't entirely wrong. There are giants down there. Some we've met, some we've measured, and some remain shapes in the dark, detected only by sonar or by brief flashes caught on deep-sea cameras. And then there are others, possible, theoretical, still unconfirmed. Creatures that could exist, based on physics, biology, and hints scattered across the abyss. We'll get to all of them. But first, we have to descend. Right now, imagine the surface ocean at night. A calm, dark sheet stretching to every horizon. Waves roll slowly, almost lazily. There's a quiet the daytime never has, because everything loud has disappeared into sleep. Boats, engines, birds. Just beneath that still surface, life continues. Fish move through drifting plumes of plankton. Jellyfish pulse with soft rhythm. Nothing unusual yet. This first layer, the epipelagic zone, is still the world of familiar creatures and warm currents. But the giants we're searching for don't live here. They live far below. And to reach them, we have to sink through thousands of meters of water, layer by layer. Before we go further, we should understand something simple. The deep sea creates giants, not out of myth, but out of physics. At great depths, the rules change. Food is scarce. Light is gone. Predators move slowly, conserving energy. And in these conditions, some species grow larger, not smaller. This dimming of color is one of the first barriers to giant life. Most large animals on the surface rely on vision, at least partially to navigate, hunt, or avoid predators. Down here, that advantage dissolves. Eyes grow larger or disappear entirely. Shapes become simplified. Movements slow. And yet, some creatures adapt by growing bigger, not smaller. A pattern marine biologists call deep-sea gigantism. It doesn't apply to every species, but it appears often enough to be more than coincidence. Whatever the cause, the result is the same. The deeper you go, the stranger and larger life becomes. We'll explore examples soon. But for now, Imagine us leaving the surface behind. The last glimmer of moonlight fades above us as we cross 200 meters. This is where the twilight zone begins. Here, shadows rule. Creatures sense movement rather than seeing it. Some drift with long trailing filaments that glow faintly blue. Others retreat into darkness when they sense pressure changes, avoiding predators that hunt with silence instead of speed. This zone hosts the first category of giants, animals that never come close to the surface, yet aren't as extreme as the abyssal species below. One of the most famous is the giant oarfish. You may have seen pictures. Long, silver, ribbon-like, with a red dorsal fin and eyes that seem built for twilight. Oarfish grow over 11 meters long, making them the longest bony fish on Earth. But despite that size, they're incredibly thin, drifting more than swimming. They're one of the first hints that the deep sea holds beings shaped by rules unlike anything on land. But the oarfish isn't one of the giants we're looking for tonight. It's impressive, but not mysterious. Scientists have observed them, measured them, and filmed them. The giants we're searching for lie far deeper. And so we continue downward. The twilight dims. Colors disappear. Red vanishes first, then orange, then yellow. By the time we reach 800 meters, the world is blue fading into black. This is where the largest migration on Earth happens every night. Billions of animals rising and sinking with the moon. But even they are not the giants we're following, because those giants live in the next layer. The midnight zone. The first real shift in the descent happens long before the darkness becomes total. It begins when the surface brightness thins out, and the water takes on a muted, filtered tone, as if the world above is losing interest in following you any deeper. The colors begin to drain away. Reds fade first, then oranges, then yellows. What remains are the cooler tones, blues and grays, lingering longer because they travel more easily through water. This dimming of color is one of the first barriers to giant life. Most large animals on the surface rely on vision, at least partially to navigate, hunt, or avoid predators. Down here, that advantage dissolves. Eyes grow larger or disappear entirely. Shapes become simplified. Movements slow. And yet, some creatures adapt by growing bigger, not smaller. Marine biologists call this the deep-sea gigantism trend. It doesn't apply to every species, but it appears often enough to be more than coincidence. Certain kinds of crustaceans, worms, jellyfish, and cephalopods reach sizes in the deep ocean that they never achieve in the shallows. Theories exist, but none fully explain it. One idea suggests that the cold helps. Lower temperatures, slow metabolism, which allows resources to be allocated over much longer lifespans. Another idea points to the scarcity of food. Larger bodies can travel longer distances on fewer calories, searching for the occasional sinking carcass or drifting particles that make up marine snow. But another factor is pressure. The deeper you go, the more the environment compresses around you. Smaller animals sometimes struggle with these stresses. Larger, more flexible bodies handle them better. This brings us to one of the ocean's most surprising realities. Some giants succeed not by being strong, but by being soft. Not muscular, not armored, but gelatinous, slow, flexible, able to compress under pressure without breaking. This trait becomes more important the deeper we descend. As we drift through the last stretch of the twilight zone, another figure begins to appear. At first it seems like a long, dim streak, trailing through the water like a faint smear of light. But the closer we imagine coming, the clearer it becomes that this is no smear. It is an animal made of thousands of coordinated individuals. A siphonophore. Some documented siphonophores stretch longer than blue whales, reaching 30 to 50 meters, possibly even more. These are not speculative giants. They're real. They exist today, slowly drifting through the dark water, using tiny stinging cells to capture prey. Their bodies are fragile, so much so that submarines rarely see them intact. A nearby current or a bright light can tear them apart. They are giants of delicacy, beings designed not for competition, but for persistence. If such creatures exist at the edge of twilight, the abyss offers room for even larger forms. This is where speculation becomes scientifically reasonable. The deeper we go, the more we realize how much space remains unmapped. Entire trenches have never been surveyed by crude submarines. Many autonomous vehicles have only followed narrow paths, leaving the vast, surrounding darkness untouched. Inside this unseen expanse, there is room for animals larger than anything we've studied. Not monsters, not impossibilities, just scaled-up versions of known life strategies. For example, a siphonophore-like organism stretching well over 100 meters. Its body arranged like a slow-moving, ribbon-shaped colony drifting through still water. The physics don't forbid it. The ecology doesn't forbid it. The pressure doesn't forbid it. What limits such beings is fragility, not feasibility. And in the abyss, fragility is not always a weakness. When nothing fast or strong is hunting you, being soft becomes a successful design. We continue our descent, letting the last traces of blue fade out. Vision offers little now. Most life forms become silhouettes. Shapes glide through the gloom, barely outlined by faint flashes of bioluminescence. This is the threshold between what we know and what we guess. And just beyond it, another giant waits. One of the most discussed candidates in the realm of real yet unconfirmed megafauna is an organism sometimes described as a megajelly structure. Not one single species, but a general category of theoretical animals based on jellyfish and comb jellies. The idea is simple. If gelatinous life can reach large sizes in shallower depths, nothing prevents far larger, slower, wider organisms from evolving in the deep ocean. The pressure does not harm jelly-based tissue. The cold stabilizes it. The darkness suits animals that don't rely on eyes. Some marine biologists suggest that if such creatures exist, they might resemble drifting domes, hundreds of meters across, nearly invisible unless illuminated. They would move slowly, using faint pulses of water to maintain position. Their feeding structures could trail far behind them, catching whatever particles or tiny organisms drift into reach. Again, none of this breaks biological rules. It simply stretches them to scale. We're now well beyond the depths where sunlight offers any guidance. The water thickens with pressure. The temperature falls close to freezing. And yet, life persists. This is where the real giant squids finally become contenders. For centuries, they were legends. Stories of tentacles rising from the deep. But today, we know they're real. We have footage, specimens, and encounters with their scars left on whales. The largest recorded individuals exceed 13 meters. But estimated maximum size remains uncertain, possibly larger. Their lesser-known relatives, the colossal squids, may be even heavier, with thicker bodies and powerful hooks along their arms. Most sightings occur when whales surface with injuries or carcasses wash ashore. It's reasonable to assume that the largest individuals have never been seen. Large predators often avoid the places where humans can detect them. The true extremes of their range remain hidden in the abyss, where even submarines rarely go. This raises a question scientists still cannot answer. If giant squid exist and colossal squid exist, could there be even larger cephalopods? Not outlandish fantasy, just a continuation of the trend. A cephalopod 20 meters long is within the range of feasibility. Even 25 meters isn't impossible, depending on structure and prey availability. But beyond that, the limits tighten. Musculature becomes harder to maintain. Metabolism becomes complex. But still, nothing concrete forbids the idea of an extreme outlier. Perhaps rare, perhaps deep, perhaps unseen. And in a world where so many carcasses sink to the bottom without ever being recovered, it's possible for such creatures to live and die without leaving evidence we can easily find. As we continue drifting downward, another idea emerges. This time based on something real and measured. Giant amphipods. These small crustaceans, normally only centimeters long near the surface, have been found reaching over 30 centimeters in deep trenches. Their increase in size follows similar logic to other deep-sea giants. Colder water, slower metabolism, and fewer predators. If a tiny scavenger can grow to the size of a human forearm, the scaling potential across other ecosystems becomes clear. But amphipods are merely one piece of the pattern. Across the deep ocean, worms grow larger. Sea spiders grow larger. And isopods grow larger. This is not rare. It is common, which means the next step is not wild speculation. It's simple extrapolation. If many groups trend toward gigantism with depth, the abyss likely hosts species we have never seen that follow the same rule. Just at a scale we aren't prepared for. Down here, the rules change. And as the darkness thickens around us, the presence of large, slow, unseen beings becomes less hypothetical and more expected. The last threads of daylight fade behind us as we sink, and the water around us turns from dim blue to a dense, smoky black. Even though this is only the beginning of the deep zones, the shift feels immediate. Shapes blur. Motion becomes slower. Everything narrows into silhouettes and faint glimmers. Here, the ocean begins to select for creatures built for presence rather than speed. Their bodies stretch into long, drifting forms. Their movements settle into a slower rhythm, almost meditative. And their existence starts to feel less like something biological and more like something the deep itself sculpted. The giants that live here, and the ones that may exist even deeper, are not mistakes of evolution. They're solutions. Large bodies store energy. Large forms withstand pressure. Long limbs or tentacles help sense movement in total darkness. Slow metabolisms thrive when food is scarce. The deep does not just tolerate giants. It rewards them. And every few years, our instruments catch a brief glimpse of something we cannot explain. A long shadow sliding past a submersible window. A sudden drop in sonar, as if a massive shape crossed the beam. A swirl of disturbed sediment where nothing should have been moving. We never catch the full picture, but we catch enough to know something was there. And as we drift farther down, the idea becomes less speculative. Somewhere in the dim twilight, the ecosystem transitions. Small, fast fish become rare. Slow, drifting organisms become more common. Predators begin to rely less on vision and more on sensing vibrations or faint electrical fields. The further we go, the more we feel the weight of this place. Not just physically, but conceptually. We're entering a world that does not care about the surface. A world that has never depended on sunlight. A world that may hold species larger than anything we've officially discovered. The giant squid offers a useful example of how recently our knowledge updates. We didn't film a living specimen until 2012. And even that was a small individual. If a creature that large avoided human detection until recently, what else could be hiding below? Something bigger, slower, older. When scientists model the deep-sea food web, they routinely encounter an odd imbalance. Far more biomass disappears into the abyss than we can account for. Something is eating it. Something large. Something that lives beyond the reach of most submersibles. We can't say what it is, but the equations hint at something with a presence. Something massive. As we sink past 500 meters, the last biological traces of daylight vanish. This is the beginning of the midnight zone. And everything changes here. Pressure increases at a rate that is difficult to comprehend. At this depth, every square inch of your body would feel dozens of atmospheres of force. Keep going, and it climbs into the hundreds. Animals here have adapted in extraordinary ways. Flexible bodies, gel-like tissue, minimal air pockets, slow metabolic rates. If you want to hide something enormous, this is the place. The silence is different, too. It's not empty. It's dense, thick, almost physical. Sound travels well here. Footsteps would echo for kilometers if footsteps could exist. And in this vast quiet, being large is not a disadvantage. It lets a creature move slower, hear better, conserve energy, and take advantage of every drifting scrap of food. Scientists suspect that some species down here may reach lengths or masses well beyond anything we've formally recorded. Not because we've seen them completely, but because the patterns of the ecosystem almost require something that size to make sense. Long siphonophores over 40 meters. Colossal jelly organisms drifting in near-infinite curtains. Swarms of giant amphipods the size of human hands. And occasionally something larger. There are rare sonar scans showing immense, slow-moving forms that don't fit any known profile. Their shapes don't match whales, sharks, or giant squid. The signatures are smoother, less structured, almost amorphous. Something drifting, not swimming. Something big enough to distort the water column around it. Some oceanographers suggest ultra-giant siphonophores, colonies of organisms working as a single entity, could reach sizes far beyond anything we've officially confirmed. Hundreds of meters across, living like floating cities. Others think enormous, gelatinous predators could exist, feeding on midwater fish in slow, silent ambushes. We cannot rule it out. The deep rewards stillness. It rewards bulk. It rewards patience. Everything we know about deep evolution points towards size as a viable strategy. Down here, a giant does not stand out. It blends in. And as we descend, the water grows colder. The light fades completely, and the sense of scale dissolves. We could be next to a creature the size of a bus and never know it. Or a creature longer than a train. Or something larger still, drifting like a continent of flesh in the dark. No sonar beacon, no spotlight, no submersible window could capture it fully. It would be a presence more than a shape. A slow, living shadow. This is the threshold of the abyss. A place where size, silence, and darkness merge into one ecosystem. A place where giants, real giants, are not just possible. They're probable. This is the threshold of the abyss. A place where size, silence, and darkness merge into one ecosystem. A place where giants, real giants, are not just possible. They're probable. And as we cross that threshold, drifting gently into a region where even the memory of sunlight has vanished, we enter the midnight zone proper. We're leaving the twilight waters behind now, drifting gently into a region where sunlight no longer exists. The surface world, with all its familiar colors and shapes, is far above us. Even the faint, dusty blue glow that once filtered down through the upper layers has vanished. Down here, light is not just rare. It is impossible. This is the midnight zone, a world defined by darkness, pressure, and slow movement. And if the oceans are going to hide genuine giants, or creatures that push the limits of biology in ways we've barely imagined, this is where they would begin to appear. Take a moment and let the space around you settle. Imagine the water stretching in every direction. Thousands of meters of darkness. Cold as a winter cave. Still as a held breath. Nothing rushes here. Nothing moves quickly unless it needs to. Everything conserves energy. This is the first region of the ocean where we stop expecting creatures to fit familiar patterns. The deep sea rewrites rules. And the further we go, the stranger the rules become. In the twilight zone above, size is tightly controlled by available resources. There's enough sunlight-driven productivity trickling down to support small fish, small sharks, small jellies. But in the midnight zone, the pressures shift. Here's where it helps to slow the picture down. In near-total darkness, visual predators become far less common. Long-distance chases become rare. Speed is replaced by patience. Creatures that live here begin relying on low metabolisms. Slow drifting behavior. Wide foraging ranges. Bodies built to handle crushing pressure. And in an environment like this, being larger can actually be more efficient. Large bodies store more energy. Large bodies withstand pressure more easily. Large bodies drift more gracefully across long distances. Almost every deep-sea lineage has at least one species that went big. The vampire squid, the giant tube worm, the colossal squid, the giant amphipod, the giant isopod, the bigfin squid, the giant jellyfish, the megamouth shark. And these aren't outliers. They're signals. Signals that the deeper we go, the more the ocean rewards slow, oversized forms. It's one of the reasons scientists believe the midwater depths are capable of hiding organisms far larger than anything recovered so far. Not monsters, but immense, slow-moving animals adapted to silence and darkness. If you've ever felt the weight of deep silence pressing against you, imagine that sensation multiplied thousands of times. At these depths, the pressure doesn't simply influence life. It sculpts it. Every 100 meters deeper means another layer of weight. Go down 1,000 meters, and the pressure is like balancing a car on every square inch of your body. Go down 2,000 meters, and the pressure becomes the weight of small buildings. Yet life persists. And not just small life. Not just fragile forms. Some of the largest invertebrates ever discovered live within this band of water. Their bodies are flexible, gelatinous, and buoyant, allowing them to grow without needing rigid skeletons that would collapse under the weight. Pressure here encourages soft, drifting forms, expansive bodies, long, flowing tentacles, slow metabolisms, balloon-like constructions of tissue. Creatures like siphonophores, colonial animals that can reach well over 150 feet long, are prime examples. And here's the interesting part. Even the largest siphonophores discovered so far may not be the largest that exist. They often live in deep, hard-to-reach pockets. They fall apart when disturbed. They avoid ROV lights. They fragment when captured, meaning our measurements are incomplete at best. If an organism that's essentially a living ribbon can reach 150 feet, the theoretical ceiling becomes far higher. And the midnight zone gives these organisms room and time to reach those extremes. Drifting is not a passive act here. It's a strategy. A large organism can let the deep currents carry it for weeks, even months, without burning much energy at all. This is one of the reasons scientists suspect that slow-moving giants could exist beyond our current records. Imagine a creature shaped like a sail or a curtain or a series of linked bells drifting in the dark. Not a predator racing through the water. Not something explosive or violent. Just an animal that has grown into the empty space around it, filling the water column like a living tapestry. Science has a term for this kind of creature: ultraplanktonic megafauna. Hypothetical, but physically plausible. These would be animals that behave like plankton, drifting freely, barely controlling their movement, but at lengths that stretch the imagination. 100 feet, 200, perhaps more. Not because the deep sea requires giants, but because it allows them. When nothing limits your size, not predators, not light, not physical boundaries, growth becomes a function of opportunity, not constraint. And in the midnight zone, opportunity comes in the form of quiet water and endless time. Once you reach depths below 800 to 1,200 meters, the reports from submersible operators and ROV pilots begin to shift in tone. Many describe shapes passing just beyond the lights. Enormous, curtain-like forms retracting into the dark. Long lines drifting vertically like pillars. Organisms so large they disappear into darkness before the cameras stabilize. These aren't sensational claims. They're careful, technical observations from researchers who understand optical distortion, sediment interference, and instrument artifacts. And almost all of them say the same thing. We saw something, it was very large, and it moved. But the deep sea resists clean answers. Some encounters involve tentacle-like structures that extend beyond the camera frame. Others involve pulsing motions too large to be jellyfish, but too slow to be squid. A few describe masses that look like drifting, translucent walls, as if a living sheet, the size of a building, had folded itself away in silence. None of these observations prove the existence of ultragiants, but they point to something important. In the midnight zone, our field of view is so small, the organisms could easily be far larger than we realize. If a creature's body extends beyond the cone of artificial light, we have no way of measuring its true size. And the deeper we go, the more common this becomes. Before we drift further, hold on to one quiet truth. The midnight zone is not empty. It is full. Full of movement, full of drifting shapes, full of slowly pulsing organisms we rarely see in full context. Some are just large. Some are enormous. Some are theoretical, but physically possible. And some may only reveal themselves when we reach deeper, colder layers below. A threshold is a subtle thing. Most people imagine boundaries as sharp lines. But the ocean rarely gives us neat borders. Instead, it gives us gradients. Soft changes. A slow dimming of light, rather than a sudden curtain dropping. Here, in the transition toward the true midnight zone, everything becomes quieter, thicker, and more deliberate. The water feels heavier. Sound travels differently. Even time seems to stretch, as if the deep is asking you to slow your thoughts before entering the next layer. What makes this threshold so strange is that it is neither shallow nor deep, neither familiar nor entirely alien. It is a middle world, suspended between two realities. And in this in-between place, giants begin to make more sense. Not legendary monsters, not cinematic exaggerations, but organisms shaped by pressure, scarcity, and slow movement. Conditions that quietly reward large size. As we pause here, drifting in the last traces of blue light fading from above, it becomes easier to see how this begins. The animals that inhabit this zone have already committed to darkness. Their eyes enlarge. Their pigments fade. Their bodies grow more gelatinous, more energy efficient. Some glow faintly with bioluminescence, not for defense or aggression, but simply as a byproduct of the chemistry that sustains them. And then, deeper still, faint outlines begin to appear. Long threads, soft silhouettes, drifting shadows that stretch beyond the limits of your vision. Most are harmless. Most are slow. But their size hints at the strategy of this depth. Grow large enough to drift efficiently. Grow long enough to trap food without chasing it. Grow broad enough to conserve every bit of energy in a world where energy is scarce. This is where true gigantism begins to take hold. Not suddenly, not explosively, but with a patient, steady logic. Because down here, being big is not a burden. It is an advantage. A larger body stores more energy. A longer fishing line of tentacles collects more drifting plankton. A broader bell of a jelly creates more lift for slow, effortless movement. A larger presence makes predation less likely because nothing wants to waste energy on an uncertain meal. And so, as we drift deeper, the silhouettes lengthen. A siphonophore tens of meters long. Its tendrils arranged like delicate chandeliers. A giant larvation, inflating and shedding its gelatinous house over and over. A combed jelly the size of a car tire, drifting like a slow beacon of rippling light. A squid with arms that curve into the dark, like the ribs of an ancient structure. None of them are monstrous. None of them are aggressive. Yet each one is undeniably giant in its own way. Before long, the remaining traces of sunlight vanish entirely. What little blue shimmer remains dissolves into black. And now the threshold truly begins. Here one truth becomes clear. The midnight zone is not empty. Not full in the way shallow seas are full, but full in a quieter, slower, gentler sense. Full of drifting organisms that rarely collide. Full of long-lived animals that move only when needed. Full of shapes that stretch farther than expected. As if the deep water encourages every species to spread out, to extend, to use the vast vertical space available to them. Some giants at this depth are confirmed. Others are theoretical, but permitted by physics. A few are speculative. Hints caught on sonar, shadows detected on deep sensors, glowing chains recorded on autonomous submersibles. Their reality is not in question. Only their full form remains unseen. This is because, at this depth, even giant animals can remain invisible. The water absorbs and scatters light. Bioluminescence conceals as much as it reveals. And most importantly, these giants move slowly enough to avoid detection. Slowness here is a form of invisibility. As we hover at this threshold, the environment changes again. The water pressure increases until every square inch would crush anything not built for it. The temperature falls. The density of life thins only slightly, replaced by organisms that live for decades, sometimes centuries, feeding on whatever the ocean above sends drifting downward. A single ribbon of marine snow falling through the void may sustain an organism all day. Food scarcity encourages unique strategies. Some of the giants here are long rather than bulky. Some are wide rather than tall. Some are thin enough to be almost invisible until you drift close enough to see the delicate ripples of their movement. This is where researchers first noticed the unusual pattern. Organisms tend to become one of three things in this depth: strangely long, strangely wide, strangely clear. Length allows them to maximize contact with falling food. Width gives them the buoyancy to drift without spending energy. Transparency conceals them from predators in a world where light is nearly gone. The largest theoretical giants, those that may exist but have not been confirmed, likely follow these same principles. Not monstrous, not violent, just extremely efficient. A particularly striking example is a known siphonophore recorded at over 45 meters long. Not thick, not muscular, more like a floating net, each segment performing a different task. If one species can reach 45 meters, it raises a simple, unavoidable question. What else might reach 60? Or 80? And then, what if something reached 100? Organisms with no bones, no heavy muscles, no need for fast movement could theoretically extend indefinitely, limited only by energy availability and structural stability. Scientists already acknowledge this possibility quietly, without drama. The deep sea may host the longest animals on Earth, and we may have never seen them. Not out of secrecy, but because they live where we cannot go often enough, long enough, or quietly enough to observe them. This threshold of darkness is not where giants peak. It is where they begin to change shape, adopting forms optimized for absolute darkness. Soon, as we drift deeper, the giants will no longer be occasional. They will be the dominant strategy for survival. But before we take that step, it is worth pausing here one last time. Because in the next layer, something shifts. The darkness stops being a simple absence of light and becomes a physical presence, as if the water itself has thickened. Sound becomes muted. Movement becomes slower. The sense of scale becomes distorted. And the possibility of encountering something enormous Not theoretical, not exaggerated, but simply following the logic of the abyss, becomes more natural than strange. As we move deeper, the water around us changes again. Though nothing visible marks the transition. There is no line, no boundary, no sudden shift in color. The ocean simply grows heavier, colder, and far quieter. The last traces of twilight fade away. Even the faintest suggestion of surface light is gone. Here, life becomes almost entirely dependent on two things: energy that drifts downward from above, and bodies adapted to an environment that does not reward speed or agility. It rewards endurance. It rewards efficiency. And it rewards size. Not for the reasons we associate with land animals. Not for dominance, hunting power, or display, but for survival. Large bodies lose heat more slowly. Large bodies store energy more efficiently. Large bodies move with less effort in dense water. And large bodies can drift for weeks or months without feeding, surviving on internal reserves. Down here, those advantages add up, which is why the deeper we travel, the more reasonable the giant strategy becomes. Imagine something long, not fast, not coordinated in the way we expect of predators. Just long. A body like a ribbon. A structure built of repeating segments, barely visible except for the faintest outline. A creature that may stretch tens of meters, maybe even over 100, yet move with the slow calm of a drifting branch. These are siphonophores. The confirmed species can reach nearly 150 feet, or about 45 meters, already longer than the largest blue whale. But the ocean is not limited to what we have confirmed. It has the space, the pressure-stable environment, and the energy conditions that make longer chains physically possible. Some scientists quietly propose that much larger siphonophore-like organisms could exist deeper down, hidden in layers too difficult for ROVs to navigate for long periods. It isn't speculation for entertainment. It is speculation grounded in basic physics. The deeper you go, the more stable the water conditions become. Less temperature fluctuation, less disruption from storms or surface currents, more predictability. And in predictable environments, large, slow body plans thrive. Predators in shallow water chase. Predators in twilight water stalk. But predators down here wait. They hold position. They conserve energy. They let the ocean deliver food to them. A giant creature in this zone does not need to sprint or chase. It simply needs to exist efficiently. That alone makes giant forms practical. Whale falls, sunken whale carcasses, provide enough food to support entire ecosystems for years. A massive, slow-moving scavenger could drift between these food sources, feeding rarely but heavily. Long, rope-like organisms could extend feeding structures dozens of meters wide. Large gelatinous predators could drift with tentacles spread like nets. Nothing about this environment discourages large forms. Most forces down here encourage them. People often assume the deep ocean is empty because we rarely capture giants on camera. But the reasons are simple. ROVs produce noise that scares large animals away. Lights disrupt and scatter deep-sea organisms. Most camera missions stay within narrow corridors. Giant creatures may move vertically, not horizontally. Some may spend most of their lives below the range we can reach. The absence of evidence is not evidence of absence. especially when our ability to search is limited to short windows and narrow paths. Imagine trying to document wildlife on land, but with only a few flashlights, a small noisy vehicle, and the ability to explore just a straight 200-meter path at a time. You would miss most large animals, even if they were all around you. The deep ocean is no different. Most of the planet's habitable volume exists in this darkness. Not the continents, not the surface waters, but the deep layers that descend into trenches. That volume is immense. There is room, literally, for enormous creatures to thrive without encountering humans or human technology. And unlike land, there is no gravity-driven penalty for size. The ocean supports weight naturally. A creature 50 meters long does not feel heavy here. It simply feels present. Here is a quiet truth scientists remind themselves of. We understand less than 5% of the deep ocean. Some estimates suggest it is closer to 1%. That is not a poetic claim. It is a technical one. The deep ocean is logistically, economically, and physically difficult to study. We visit it in brief, limited missions. We explore tiny paths instead of wide regions. We rely heavily on remote instruments that have limited vision. This means that many species we consider rare may not be rare. They may be common. We simply do not look in the right places often enough. And when it comes to giants, this possibility becomes even more realistic. Large creatures require space. The deep ocean provides that space. They require stability. The deep ocean offers that stability. It is rational to assume many large or very large species exist beyond our current ability to document. Even greater depth exist beneath us still. The abyssal plains and the hadal trenches. Those environments further amplify the advantages of size. In those regions where pressure reaches levels that require special adaptations, slow metabolism becomes the norm. Large animals with slow metabolisms can thrive where small, fast-living species cannot. Before we go, it's worth holding onto one grounding realization. Every major shift we've seen so far, from the well-lit surface to the shifting twilight to the still darkness of the midnight zone, has pushed life toward larger, slower, more efficient designs. Nothing about this trend stops here. If anything, it becomes even stronger as we move downward. So as we settle into this last moment before sinking deeper, a simple idea becomes clear. Giants are not anomalies in the deep. They are a logical outcome. When you remove the constraints of light, warmth, and rapid movement, and replace them with stillness, density, cold, and constant pressure, size becomes one of the most effective survival strategies available. And in a realm where our tools can barely reach, the largest beings may drift unseen. Not mythical, not impossible, not extraordinary, but simply adapted to the world around them. The thought lingers for a moment longer, quiet and steady. Giants aren't rare in the deep. They're part of the architecture, part of the logic that governs everything beneath the reach of the sun. And as we let that settle, the water around us seems to exhale just slightly, as if the ocean appreciates being understood on its own terms for once. Now we move again. Not fast. Never fast down here. Just a slow, steady slip downward, letting the weight of the sea fold in around us. We're leaving the midnight zone behind us, though leaving is the wrong word. Nothing in the deep is ever gone. Every layer continues to affect the ones below it, like a memory pressed into water. But the lightless plane we drifted through above is now becoming a dim ceiling, a pressure-laden threshold above our heads. Below us, the darkness grows thicker in a way you can feel more than see. Pressure gathers. Temperature slides downward. Movement becomes slower, heavier. We're entering the early edge of the abyss. Here, the ocean becomes something different. Not hostile, not empty, not violent. Just profoundly indifferent. It is a world where everything must justify the energy it uses. And everything that survives does so by adopting shapes and strategies that make sense in a place this still. If there are giants here, they don't feel oversized. They feel inevitable. A few 100 meters deeper, the textured impressions of the midnight zone fade away. No more faint glimmers from bioluminescent flecks above. No more drifting silhouettes of lanternfish pulsing in patterns. Now it is just us, sinking into a smoother, slower world where motion itself seems optional. The water becomes denser. The dark becomes deeper. And the scale of things begins to shift. At these depths, even the ordinary starts to feel massive. A drifting comb jelly, no bigger than a dinner plate, seems to take on an exaggerated presence simply because the space around it is so vast. A slow-moving squid, maybe a meter long, appears to glide in a way that suggests the possibility of much larger relatives nearby. It's not imagination. It's environmental logic. Down here, survival is about efficiency, and efficiency often favors size. The deeper we drift, the more that rule asserts itself. At around 2,000 to 3,000 meters deep, we cross the threshold where the ocean stops presenting familiar forms entirely. The species here are adapted to pressures that would flatten steel. Their bones, if they have any, are flexible. Their tissues are soft, gelatinous, built to distribute pressure evenly. And the largest among them take advantage of something surprising. The deeper you go, the easier it becomes to be large. It sounds backwards, but in this realm it's true. When an organism doesn't have to fight gravity, when it can float in water of nearly the same density it is, and when the cost of movement is low because movement itself is slow, size becomes cheaper, not more expensive. The giants here don't fight the water. They let the water carry them. And that allows them to grow in ways surface creatures cannot. A quiet shape drifts past us. Not close, not defined, not immediately recognizable. Just a suggestion of something long, ribbon-like, moving without urgency. It could be a giant siphonophore, one of those colonial organisms that can stretch longer than any whale on Earth. Or it could be a separate species altogether, one that only appears this deep, where our submersibles rarely travel. We don't chase it. We don't speed up. We just continue sinking. Below this depth range, the ocean floor is still far away. We're not near the bottom yet. We're still in open water, suspended in an enormous volume of darkness, where large, slow life finds room to exist unnoticed. And this is where human imagination has always flickered. We've explored the surface of Mars more thoroughly than this layer of our own planet. There are canyons down here, water-filled trenches deeper than the height of Mount Everest. There are plains larger than continents, all submerged in eternal night. There are currents, invisible but powerful, carrying nutrients, carcasses, and organisms thousands of kilometers. And in all of that space, we've confirmed only a fraction of what lives here. This is the layer where giant begins to blur into unknown. Confirmed giants, colossal squid, giant isopods, huge jellyfish, are only the surface-level representatives of a deeper pattern. For every species we've recorded, each one has close relatives we've seen only once or twice, or not at all. Except for stray tentacles, strange sonar signatures, or unexplained drifting shadows. This is where theoretical giants start to feel plausible. Not mythical, not fantasy, just reasonable. 100-meter siphonophore. Physically possible. A jelly organism the size of a small building. The structure could support it. A pressure-adapted fish longer than any known shark. Not unreasonable given the density of biomass at these depths. The darkness doesn't hide monsters. It hides scale. And as we fall deeper, scale becomes harder to interpret. A slow-moving organism might be close and small or far and enormous. A glint of bioluminescence could belong to something palm-sized or something 10 meters long with only one glowing organ. Sound travels differently too. Faster, farther, making distant movements feel close. Everything becomes uncertain by design. That uncertainty isn't terrifying. It's calming in a strange way, because it means the ocean still holds mysteries we haven't crushed under our need to categorize. Somewhere below us, in a layer we're drifting toward now, the last confirmed giants give way to speculated ones. This is the part of the ocean where our ROVs rarely go, where submersibles can't stay long, and where sensors struggle to interpret the signals they detect. And yet, scientists agree. It is highly likely that larger organisms live here than anything we've seen above. We'll reach that zone soon. But for now, we hold here in the early abyss, letting the world become quieter, heavier, and more expectant. The deeper we go, the more the ocean feels like it's waiting to reveal something. Something large, something slow, something that belongs to this realm in a way we never could. The deeper we drift, the more the water changes around us. Not visually, because sight is already fading. Not through temperature, which has already fallen to near freezing levels, but through compression. Down here, pressure is not a force that acts occasionally. It is constant. It is absolute. It is the fundamental sculptor of every living thing that survives in this darkness. And it is the quiet architect of giants. Because pressure does not simply squeeze. It reshapes. It limits. It removes entire categories of survival strategies and replaces them with new ones. At these depths, speed becomes inefficient. Bursts of movement become costly. Muscle mass becomes a luxury very few organisms can afford. What remains is a kind of biological minimalism, where the simplest solutions win. Longer bodies, looser tissues, slow metabolisms, expansive forms that drift rather than swim. This is why giant forms are not rare here. They are the natural outcome of an environment that rewards slow growth and steady presence. As we continue downward, the effects become more pronounced. For humans, the pressure a few thousand meters down would be instantly crushing. Metal hulls groan under the strain. Cables thin. Lights fail. Electronics undergo stresses they were never meant to endure. But for deep-sea organisms, this pressure is not a threat. It is simply part of the background environment they evolved alongside. Their bodies are structured to accommodate it. Many have no air-filled spaces at all. Others rely on tissues that compress without damage. Some, like certain giant jelly organisms, are almost entirely fluid. allowing them to exist under forces that would flatten most terrestrial life instantly. This soft, compressible biology is one of the reasons giants thrive here. A large, gelatinous body is easier to maintain under pressure than a smaller, rigid one. The rules of physics and biology blend into a single principle. A creature that drifts, expands, and distributes its mass broadly can survive deeper than anything that relies on structure or density. And so, giant forms emerge almost naturally. They are not here because the deep sea encourages monstrosities. They are here because growth offers stability, and stability offers survival. By now, sunlight is not merely faint. It is gone entirely. Even bioluminescence, once scattered and sporadic, becomes more specialized. Lights become signals. Signals become rare. And rare signals become valuable. But scale continues to grow. Some of the jelly-based organisms in this depth range may extend tens of meters in length. Others, like certain siphonophore colonies, can reach over 40 meters. Not as single animals, but as linked modular bodies functioning as one. These colonies blur the line between individual and collective beings. But even these known giants may be small compared to what could theoretically survive deeper below. Because once light is no longer a factor, the evolutionary landscape becomes almost entirely dominated by energy efficiency. And larger bodies, spread over broad distances, are incredibly efficient in low-energy environments. This is why, even without direct sightings, researchers consider it plausible that much larger gelatinous or colonial forms may exist below the reach of our current tools. Nothing mythical. Nothing supernatural. Just organisms shaped by cold, pressure, and time. As we move down this twilight threshold, we pass through a region where known giants exist at the edge of our understanding. Giant squids, with their long trailing arms, appear and disappear without warning. Colossal squids, larger and heavier, drift farther below. Their bodies adapted for slow cruising rather than hunting bursts. And yet even they are not the final frontier of large deep-sea life. Their size, impressive as it is, represents what humans have confirmed. It does not represent what is possible. Because the deeper layers, the ones far beyond consistent observation, create conditions where entire categories of life could expand far beyond what we have documented. Pressure supports their structure. Cold slows their growth, but extends their lifespan. Darkness frees them from constraints of camouflage and visual predation. By the time we drift past this zone, the idea of what a large creature is becomes fluid. A giant may not resemble the animals we know. It may be a column of soft tissue drifting for hundreds of meters, or a ribbon-like organism folding through the water, or a colony the size of a building, undulating in slow, continuous rhythm. These possibilities are not speculative fantasies. They align with biological principles already observed in smaller species. If a siphonophore, a known organism, can stretch longer than a blue whale, then the deep layers below could support forms even larger, shaped by the same rules. The pressure continues increasing. The temperature stabilizes near freezing. Movement slows even further. Creatures we pass here tend to drift rather than swim. Their bodies glow rarely, if at all. Many are transparent. Some are nearly invisible. This zone represents a turning point. Above, life is limited by competition and rapid movement. Below, life is limited by energy and simplicity. And here, between those extremes, Giants transition from being uncommon figures into being adaptive strategies. This is the depth where the boundary between large and very large begins to blur. It is where the largest animals we have confirmed become small compared to what might live below. And as we drift closer to the abyss, another quiet truth emerges. The deep sea does not hide giants because they are rare. It hides them because it is vast. What we have seen is only a fraction. What remains unseen may be far larger. As we continue into this part of the descent, movement becomes less frequent around us. Not because life is disappearing, but because life is becoming slower, calmer, quieter. This slow pace is precisely where giants thrive. They do not need to compete for light. They do not need to rush for food. They do not need to conserve heat. They drift, grow, expand, and persist in ways that surface animals cannot. And they do so in a darkness so complete that size becomes a nearly invisible advantage. Here, everything favors scale. Everything favors patience. Everything favors organisms able to stretch across the water column, distributing their needs over wide distances. This is the realm where giants stop being exceptions. They become expected outcomes. They become logical. They become the default strategy. The slope beneath us finally gives way. The last traces of the midnight zone fade, and we cross into a depth where the water no longer feels like a liquid. It feels like a substance with weight, a quiet mass that presses from all directions, shaping everything inside it. This is the abyss, a place without stars, without color, without memory of the surface. A world where light has never existed, not even faintly. A world defined entirely by pressure, temperature, and time measured in centuries. If the upper zones allow giants, then this place requires them. Not because bigger is always better, but because in these conditions, large size solves more problems than it creates. A bigger body stores more energy. A bigger frame loses heat more slowly. A bigger presence moves less, wastes less, and survives longer. Down here, longevity is the main currency. Endurance is the rule. Mass becomes a survival tool. And creatures, real or theoretical, adapt to that logic with startling elegance. Before we dive into the specifics of hypothetical giants, we need to understand one thing. This depth is built for life that grows slowly, ages slowly, and moves rarely. Everything here is designed for efficiency. Energy, movement, structure, metabolism. Nothing is wasted. Everything is deliberate. Even the darkness feels efficient, as if the world has settled into its final form. The abyss begins around 3,000 meters, but its nature shifts gradually. It isn't a sudden drop or a dramatic change. It's a soft fade into stillness, like stepping into a room where sound naturally refuses to travel. The deeper we go, the more the water becomes an insulating layer. Quiet, cold, and unbelievably heavy. Pressure now is thousands of pounds per square inch. More than enough to crush submarines that aren't engineered for this world. More than enough to collapse metal if it weakens or bends in the wrong direction. But living things adapt far better than machines. They become gelatinous. They become slow. They become flexible in ways that defy surface logic. They become creatures of the pressure rather than victims of it. This is the key to the giants of the abyss. Soft bodies scale better than hard ones. A whale cannot exist at these depths, not for long. Its lungs would collapse. Its rigid structure would fight the pressure rather than flow with it. But a creature made of delicate tissue, water-like muscles, and pressure-neutral anatomy, that kind of creature could grow far larger than any surface-dwelling organism. This is why many scientists suspect that if the largest animals on Earth exist today, they would exist here, not in the open ocean near sunlight. The abyss hides size effortlessly. Sound travels strangely. Light never reaches. Sonar loses detail. Remote vehicles struggle with power, communication, and navigation. A giant here does not need to be mythical. It only needs to be patient. Large, slow, quiet, and deep enough that our instruments cannot follow. Most of the species we've found so far barely hint at the possibilities. Colossal squid, giant amphipods, massive jelly formations, enormous siphonophores the size of dinner plates. But these are the small giants. They exist at the fringe of what the abyss can produce. As we sink deeper, the category shifts entirely, away from what we have found and toward what is logically possible. Not fantasy, not folklore, but the upper limits of biology in perfect conditions for size. Before we explore those possibilities, we pause here for a moment. In this first layer of the abyss, where the water settles into a permanent night, where pressure softens everything, where giants are not only possible, they are expected. The descent continues slowly, almost lazily, as if the ocean itself wants to make sure nothing here happens abruptly. Movement becomes a negotiation. Every meter downward presses a little harder, tightens the water a little more, thickens the silence until it becomes a physical thing. Down here, pressure is not an enemy. It's a sculptor, and it has spent millions of years shaping creatures into forms that do not resemble anything we know from the shallow world. Pressure forces simplicity. It forces efficiency. But strangely, it also allows size. Because when a body is mostly water, mostly soft tissue, mostly drifting surface area, there is very little for pressure to crush. It doesn't take much imagination to understand that in a world like this, giants aren't only possible, they're supported by the environment. The deeper we go, the more obvious it becomes. The water becomes denser, almost syrup-like in the way it slows everything down. There are no sudden darts of motion here. No bursts of speed. Only the long exhalation of a world that has no reason to rush. Lights from earlier depths vanish behind us entirely. Ahead, only faint sparks drift in the dark. Not stars, but organisms. Not scattered, but arranged as if following invisible currents. Slow pulses of blue. Soft lines of green. A few scattered flickers of red, the rare color in the deep. Every one of those lights belongs to something alive. Some are only centimeters long. Some are meters. Some are long enough to stretch sideways across your entire field of view. But too slender, too transparent, too ghost-like for the eye to catch as a complete shape. You notice something else too. The deeper we go, the fewer small creatures appear. This is not a place for tiny lives. It costs too much energy to survive here if you remain small. There is nothing gentle about the abyss. It rewards bodies that can store energy, move slowly, gather nutrients across large surfaces, and survive long stretches without food. And so, life answers with size. Large jelly organisms, some of them real and documented, drift like slow galaxies. Their bells expand and collapse with movements so soft You only notice them when you look long enough. Tentacles trail behind them in faint, delicate ribbons that could be 20 or 30 meters long. But those are the animals we know. The ones we've filmed by accident. The ones we caught with low-light cameras that barely survived the journey down. The truth is, at these depths, technology fails long before biology does. Remotely operated vehicles struggle with maneuvering. Their lights scare animals away or flatten the shadows that would reveal their shapes. Their propellers disrupt delicate bodies. Their metal frames create vibrations that echo for long distances. The deep does not like being looked at, which is one of the reasons we expect giants to be here. Anything large, soft-bodied, and slow-moving could drift in these depths for centuries without ever crossing into our field of detection. These creatures don't need to approach the surface. They don't need to interact with the continental shelf. They don't need to approach our nets or cameras or submersibles. They simply drift. They remain beneath the limits of light and far from the paths we travel. Pressure shapes everything down here, even time itself. Life moves slower. Growth is steady. Aging is stretched. A creature could become enormous simply because the deep gives it a long, stable life and nothing to interrupt its growth. Think of a jelly organism that grows a millimeter a week for 1,000 years. Think of a siphonophore colony that never stops lengthening. Think of a filter-feeding ribbon-like organism that expands as long as pressures remain stable. These are not fantasies. They're physical possibilities. They match the rules of biology. They follow the physics of neutral buoyancy. They align with the way pressure, temperature, and scarcity shape life here. And as we drift deeper, a subtle shift in the water tells you we've crossed into the realm where these giants would thrive most easily. A realm where weight becomes indistinguishable from stillness. A realm where the ocean is dense enough to support bodies the length of buildings without strain. Ahead, faint silhouettes pass in the darkness. Some are real. The shadow of a giant squid, long arms drifting behind it like trailing smoke. Others are less clear, more hypothetical, but supported by everything we know. Enormous whip-like forms that might belong to undiscovered colonies. Long curtains of tissue that move as a single being. Pressure is the sculptor, and darkness is the canvas. Together, they allow for life that can stretch across distances we barely understand. This is the quiet truth of the mid-abyss. If giants wanted to exist anywhere on Earth, this is where they would choose. The deeper we move, the more the water begins to behave like a different substance entirely. Up above, water feels familiar. Fluid. Open. Spacious. Down here, it thickens. Not literally, but effectively. The weight of everything above compresses it, tightens it, turns it into a medium that resists movement and muffles motion. And in this compressed, heavy quiet, the giants of the deep begin to take advantage of a rule that only works down here. The world moves slowly enough that size stops being a burden. On the surface, being enormous means needing enormous amounts of food. Enormous muscle. Enormous energy. But here in the deep, where everything lives at a slower rhythm, size becomes surprisingly efficient. A massive creature with a slow heartbeat and drifting motion can survive on far less than a similar creature near the surface. Energy conservation isn't just a strategy here. It's a lifestyle. And the deeper we descend, the clearer this truth becomes. In this pressure realm, bodies become stranger. Not all giants, have familiar outlines. Some look like drifting veils. Some resemble long, trailing cords that could stretch dozens of meters through the water column. Others move so slowly that their shape seems uncertain, shifting as if the water molds around them. Many of the largest animals down here avoid rigidity. They aren't armored. They aren't muscular. They aren't built for speed. They're built for presence, not motion. A slow pulse. A drifting glide. A body designed to occupy space without challenging the pressure that surrounds it. This is why so many confirmed giants fall into the same categories. Colossal squids with tentacles that move like curtains. Jellyfish with bells larger than a person. Siphonophores that stretch longer than blue whales. Ribbon-like creatures that appear almost immaterial. Pressure encourages softness. Softness encourages size. And size, in turn, becomes a natural outcome rather than a rare exception. Every few hundred meters we descend adds another layer of pressure. Another atmosphere, another invisible weight pressing against every surface. But strangely, this doesn't stop large organisms from existing. It enables them. Because down here, the biggest challenge isn't gravity or muscle or lift. It's avoiding collapse. And water, under immense pressure, becomes the perfect support system. A giant organism floating in dense water doesn't need scaffolding. It doesn't need bones. It doesn't need powerful muscles to hold itself up. The environment holds it. Pressure, instead of crushing, becomes stabilizing. It prevents large structures from rupturing. It allows delicate tissues to stretch farther. It allows bodies to expand without tearing. This is why the theoretical upper limits of life in the deep sea surpass anything possible closer to the surface. If an organism grows slowly enough, if its tissues remain flexible enough, if its metabolism adapts to the cold and the dark, then size becomes a matter of nutrient availability and evolutionary time, not physical impossibility. And down here, both are plentiful. In this part of the ocean, motion becomes quiet. Even a creature dozens of meters long can move without disturbing the water. No splashing. No turbulence. No trail of bubbles. Just a slow, sliding shift. This makes giants not only possible, but practical. When visibility is only a few meters in front of you, sudden movement attracts attention. Slow, drifting presence does not. It blends. It dissolves into the dark. And in a world where light never penetrates, survival often depends on being unnoticed. Some giants hide by becoming dark. Some hide by becoming transparent. Some hide by becoming so large and so slow that they simply fade into the environment around them. It is in this realm that theoretical megafauna, those yet unseen giants, could thrive. Not as monsters, not as legends, but as ordinary residents of a place built for them. As we continue drifting downward through this mid-abyssal layer, one truth settles around us. This is the transition zone. Above us is the twilight, where life still answers to sunlight. Below us is the abyss, where sunlight has never existed. Here, in this middle ground, size becomes a bridge between the familiar and the unknown. Confirmed giants live here. Possible giants drift here. Unseen giants may glide through the dark without ever approaching a research sub, a camera, or a sampling net. In this section of the ocean, the idea of a creature 50 meters long, or even 100 meters long, stops sounding impossible. and instead becomes a quiet expectation. We hover here for a moment longer, listening to the pressure, feeling the weight of all the water above, and understanding that down here, the world does not just allow giants. It encourages them. We drift downward again. Not quickly, not dramatically, just a slow, steady descent, as if the water itself is lowering us with both hands, careful not to disturb the darkness around us. This is the point where the deep stops behaving like a place and starts behaving like a pressure, a presence, a weight that doesn't crush but surrounds, settling against us the way night settles against a quiet room. The light from above has been gone for a long time. Now even the faint traces of drifting bioluminescence thin out. Here the world becomes simple, cold, heavy, silent, endless. And in this stillness, size becomes normal. The small move too quickly and burn energy they cannot replace. The large move slowly, preserving everything they have. And the enormous barely move at all, letting the density of the water do the work for them. Down here, movement is a negotiation. Every pulse of a fin, every slow undulation of a body, every drift through a current. Nothing is wasted. And because nothing is wasted, the ocean allows something unusual to happen. Life becomes big not by ambition, but by efficiency. A giant is simply a creature that solved the math of this darkness. A larger body loses heat more slowly. It moves with less effort. It survives longer. It outlasts lean years. It carries more energy reserves. It endures pressure by spreading it across a massive structure. Down here, mass is stability. And stability is survival. We are now in the zone where confirmed giants still roam, but also where the theoretical ones begin to make sense. Where the idea of a creature tens of meters long, moving only once every few hours, becomes not fantasy but physics. Before we go deeper, settle here for a moment. Let the pressure gather. Let the cold steady. Let the stillness stretch. Because below this point, the ocean stops resembling anything familiar. Below this point, the giants that exist are no longer the upper boundary. They're the introduction. This is the start of the true abyss. The world that follows is older, quieter, and far larger than the one above. Down here, the pressure rises so quickly that the numbers stop feeling meaningful. At first, it doubles. Then it triples. Then it multiplies into values the human body was never designed to comprehend. But the organisms that live here do not resist that weight. They accept it. Their bodies are shaped by it, supported by it, defined by it. And as the pressure climbs, so does the expectation that whatever survives here might not resemble familiar forms at all. The deeper we move, the more the world around us simplifies. Light disappears. Color disappears. Shadows disappear. What remains is a thick darkness, so complete that even imagination begins to adjust itself, stretching to fill the void around us. In this layer of the ocean, movement slows to kind of drifting logic. Not because the creatures are lazy, but because energy is precious and motion must be deliberate. Here, speed is a luxury. Stillness is survival. And in that stillness, giants make sense in ways they never did before. The animals that manage to grow large in this region do not do so for intimidation or strength. They grow because the environment rewards it. Larger bodies lose heat more slowly. Larger bodies store energy more effectively. Larger bodies travel long distances with minimal effort through dense, heavy water. And larger bodies filter more food as they drift through the constant snow of organic matter that falls from the world above. In this near-lightless zone, size becomes a quiet advantage. And that advantage scales endlessly. This is why the deep ocean has records of organisms far larger than their shallow water relatives. Giant amphipods, giant isopods, giant jellyfish, giant squid. Not because something mutated strangely, but because the environment gently pushed life in that direction. Where light fades, size grows. Where pressure builds, so does capability. Where predators rely on stealth rather than speed, enormous bodies become effective without ever needing to be fast. And as we follow the slope downward, we begin to sense that the giants we've already encountered may not represent the ceiling, just the beginning. Sound changes here too. It no longer travels the way it does near the surface. It bends, compresses, and warps, folding across layers of different temperatures and densities. In this warped acoustic world, large animals can communicate across astonishing distances without ever being detected by us. A low-frequency pulse from a giant organism could travel for tens, even hundreds of miles, slipping past sensors and blending with ambient noise. And we would never know. The creatures of this depth could be speaking constantly, calling, locating, navigating, while remaining invisible to everything we use to look for them. The deeper we go, the more the ocean hides. Not by accident, by physics. This is also the zone where the ocean begins to flatten life into simpler shapes. Streamlined bodies, soft tissues, minimal internal structure. No need for rigid bones or fast muscles. No need for rapid bursts of power. Everything here adapts to pressure, darkness, and stillness. But size remains one of the few traits the environment does not punish. In fact, it welcomes it. It encourages slow, steady growth. It rewards organisms that take up space without needing light or speed. It offers an entire three-dimensional wilderness where a giant creature could drift forever without encountering obstacles. And that is why this layer, more than any other, supports the idea that unseen giants may exist. Not mythical, not impossible, just large. Large enough to escape detection. Large enough to occupy territories we have never surveyed. Large enough to dissolve into darkness the moment our senses lose their range. Pressure rises again. Temperature falls again. The ocean grows heavier around us, folding inward like a world made of pure density. This is the point where we begin approaching the abyss itself, the final region before entering the true deep. And as we prepare to cross that last threshold, one idea becomes unavoidable. If the ocean wanted to hide something enormous, something slow, something ancient, something larger than anything we've confirmed, this is exactly where it would place it. As we drift downward, the water itself begins to change character. Not in temperature, not in color, but in behavior. It feels thicker, heavier. As if every meter we fall presses more insistently against us, reminding us that we are entering a place not designed for anything fragile or hurried. There is a point in this descent where human intuition stops being useful. Pressure is no longer a number we can imagine. Distance is no longer something we can visualize. And size stops being a limit. Because down here, the constraints that keep organisms small in the upper ocean simply dissolve. Energy is conserved by stillness, not movement. Body mass is supported by the density of the surrounding water. Skeletons become unnecessary. Buoyancy becomes a slow equilibrium, not an active process. Predation slows from a chase to a drift, from speed to patience. All of these traits favor large bodies, very large bodies. And this is why, at this depth, the giants begin to reveal themselves again. Not as individuals, but as patterns. A faint pulse of bioluminescence, tracing the outline of something longer than a ship. A slow ripple in the darkness that moves with intention, but without urgency. A shadow that doesn't swim so much as levitate. Rising and settling with the calm sweep of a creature that has never learned the meaning of hurry. Many of these shapes we know. Some match the size and movement of colossal squid. Some resemble siphonophores, colonial organisms that can extend for more than 100 meters in connected living chains. Some might be immense gelatinous forms, drifting with the water, almost invisible until disturbed. But others do not match any known pattern. A movement too large for a squid, too fluid for a whale, too slow for a fish. A silhouette that looks woven rather than muscled. A presence that bends the faint scattering of particles around it in ways that suggest mass far beyond anything we've confirmed. In this depth, nothing rules out the possibility that such beings exist. The physics allow it. The ecology supports it. The darkness hides it. And the pressure preserves it. This is the part of the ocean where the concept of an upper size limit becomes theoretical at best. Where an organism 200 meters long would not be extraordinary. Where a creature the width of a building could drift unnoticed for centuries. Where the ocean's silence could conceal populations of giants we have never photographed, never recorded, never imagined correctly. The deeper we go, the more plausible they become. Not monsters, not myths, just organisms that evolved in a world where being large is simply easier. And this brings us to an uncomfortable acknowledgement. If a creature existed here, enormous, slow, gelatinous, undefined, we would not know it. Our sensors are designed for motion, not stillness. Our cameras require light, which does not exist here. Our submersibles avoid depths where the pressure begins to crush metal. Our presence, when it does occur, is brief, disruptive, and inadequate for the scale of this world. If something immense lives here, it could glide past our equipment without causing even a measurable disturbance. This is why the deep sea is not described as empty. It is described as unmeasured. And unmeasured things can contain giants. As we settle deeper into this enormous, silent cathedral of pressure and darkness, the water grows colder, denser, older. Life grows stranger, slower, and more deliberate. And the sense of scale widens until it no longer feels like a measurement, but a presence. A presence we can't see. A presence we can't define. A presence that could, at any moment, move just beyond the edge of our perception. Down here, in the deepest water Earth can offer, something subtle happens. The ocean stops behaving like an environment and starts behaving like a presence. Not alive in any literal sense, but living in how it holds its silence. How it keeps its shadows. How it allows things to grow in ways the surface can barely imagine. This is the final descent tonight. Not the flashiest layer of the ocean. Not the loudest. Not the most dramatic. Just the deepest, the stillest, and the most honest part of it. A place where giants do not appear as exceptions or anomalies, but as natural results of pressure, time, and isolation. And as we arrive here, the idea becomes clearer. Some giants may be real. Some may be hypothetical. Some may drift through these depths without ever needing to be discovered. And some may continue living and dying without leaving a trace at all. Here, in this final stretch, we are not searching for answers. We are simply letting ourselves exist in the same quiet the giants exist in. A quiet older than every coastline. Older than every mountain. Older than every breath we've taken tonight. At this depth, the ocean becomes less a place we visit and more a world that does not require us. Even confirmed species behave like myths. A giant squid rising from the dark. A colossal jelly drifting in slow spirals. A siphonophore stretching longer than anything on land. An oarfish gliding like a silver ribbon that forgot to end. But the theoretical ones feel just as possible here. Creatures whose bodies spread thin instead of growing thick. Shapes that move like banners of living tissue. Organisms that pulse rather than swim. Animals built for pressure, so intense that bones become liabilities. Some of them may only exist for moments. Some may live centuries. Some may never encounter another being their own size. Some may drift past each other slowly, so quietly that even their meeting leaves no record. In this final chapter, the focus isn't on proving them. It's on understanding why they could exist and why this world is perfect for them. A place where distance has no meaning, where direction barely matters, where survival is a long, slow conversation without words. The deeper we go, the easier it becomes to see how small we are and how huge the world remains. Not in a way that diminishes us, but in a way that softens something inside us. Up above, everything moves quickly. Everything demands attention. Everything feels urgent. Down here, none of that survives. The deep has its own pace, its own priorities, its own steady rhythm that has nothing to do with our noise or timelines. And as we reach this last quiet layer, it offers something unspoken. A reminder that not everything needs to be solved. Not everything needs to be found. Not every mystery requires a spotlight. Some things can remain as they are. Distant, silent, untouched, and still deeply comforting to think about. And so here, in this last stretch of darkness, the idea we've carried with us since the very beginning finally settles into place. The deep ocean is not an empty realm waiting to be filled. It is already full. Full of movement, full of quiet strategies, full of life that has shaped itself around pressure, cold, and distance. Some of those lives are familiar. Some are enormous. Some belong to patterns we've already documented. And some drift past our lights only once, too quietly to be captured, too large to be understood, too rare to be confirmed. Down here, the giants never needed to be imagined. They simply needed space. And the ocean has always given them that. When we talk about undiscovered megafauna, when we imagine siphonophores longer than skyscrapers, when we picture dim shapes drifting in the black, larger than any camera has ever captured, we're not stretching belief. We're simply acknowledging a truth the deep has whispered for generations. If there is anywhere on Earth where giants could still live, quietly, slowly, unseen, it is here. Let that thought settle for a moment. A world beneath the world. A silence beneath the silence. A realm where size doesn't shock, it makes sense. A realm where life expands not to dominate, but simply because nothing stops it. And as we drift here at the edge of that vast black frontier, one more realization rises gently to the surface. We will never know everything that lives down here. Not because we lack imagination, not because we lack curiosity, but because the ocean keeps some of its stories for itself. And that is all right. Some mysteries don't need to be solved. Some giants don't need to be named. Some worlds don't need to be revealed all at once. Some are meant to stay quiet, slow, hidden, alive in the dark. A reminder that even on a mapped planet, wonder still exists. A reminder that size in the deep is not spectacle. It is survival. A reminder that the largest beings on Earth may pass beneath us every day, and we would never know. As we rise slowly back toward the surface, through layers of darkness, through cold that thins into something gentler, through pressure that loosens its hold, carry one simple thought with you. The world is larger than we think, quieter than we expect, stranger than we assume. And its mysteries, the vast ones, the patient ones, the silent ones, are still out there, drifting far below the light. If you're listening in bed, letting the edges of the world soften, if your breathing has slowed, if the giant forms of the deep feel less like unknowns and more like distant companions in a world you'll never have to visit to appreciate, then you're exactly where you need to be. Thank you for drifting here tonight. Thank you for letting the ocean's quiet weight hold you for a while. And thank you for spending this part of your evening or your night inside the stillness of the deep. When you're ready to sleep, you can let go. The ocean will keep drifting without you. The giants will keep moving in the dark. The world will keep its mysteries safe. And you can rest, wishing you calm wherever you are tonight.